Hello everyone, we are the group number 9 and with my group composed of Guilhem, Alban and myself, Adrien, we are going to present our project for the database course. So our domain is logistics and our project models the operations of a logistics center that act as a mediator between manufacturers and small retail shops. So in this presentation, we'll start by explaining the main idea of our logistics center. Then we'll describe our database design, and finally, we'll highlight the most interesting features in each member's contribution.
Okay, so the logistics centers offer service to smaller shops and collaborate with many manufacturers. When a shop places an order, a planner organizes the entire process from pickup at the manufacturer to delivery to the shop. The logistics center also manages several warehouses where goods are temporarily stored before delivery. Warehouse worker can look up the exact location of each item inside the warehouse. The company also owns trucks used for transportation. Each truck has specific characteristics such as capacity, volume, and condition. We have mechanics to ensure reliability, record any issue, and repair for each truck.
So our project focuses on designing an object relational database model to represent all of these processes. We use both relational tables and object types to take advantage of inheritance and complex structures. The main entities in our database are manufacturer with its ID, its name, its address, and its contact information. After that, we have the shop with, again, its ID, its name, its address, and its contact information. We have also a planner with several methods. Then we have the warehouse with its ID number, with the location, the capacity, and the current stock number. Then we have the items with information like the name, the weight, the volume, and the expiration date. And lastly, we have mechanic with its method to repair trucks. And also we have trucks with its ID, its model, its capacity, and its current status.
So we carefully design the relationships between entities using foreign keys to maintain referential integrity. So, for instance, each order is associated with a shop, a planner, and one or more items. So, one of the most interesting features is the commission calculation. So, the commission depends on the demand for transportation on a given day and on storage cost. It is calculated before confirming the order, so helping shops estimate the total price in advance.
So another interesting feature is the supplier application process. Manufacturers can submit a request to become partners to the logistics center web platform. The request can be either approved or rejected, and its status is stored in the database. We also added a warehouse lookup function, allowing workers to quickly find an item storage position, for example, by shelf number or zone ID.
So each of us contributed to different parts of the project. So I focused on conceptual and logical design, including the year diagram and the structure of the database schema. Adrien worked mainly on the SQL implementation, creating tables, object types, and inserting sample data. And Alban was responsible for queries, procedures, documentation, and also preparing this presentation video. But we also worked a lot together around the table to make sure that all of our parts were done by the way we wanted to. And together, we also ensured that all aspects from design to implementation were consistent and functional.
So to conclude, our project shows how object relational database can efficiently represent a complex business like a logistics center. So we also learn to combine the structure of relational models with the flexibility of object-oriented concepts, making data management more realistic and organized. But we also learn to work in group to communicate and also respecting the deadline. So thank you for watching our presentation.